Right. To start with, you can see that arrays is the very basic data structure we know, right? So array is a linear data structure, and it is also a static one. Although it is very basic form, it has some certain disadvantages. So one of the main disadvantage is its fixed size. I already explained you how it serves as both the advantage as well as a disadvantage as well. Just give me a second. So yeah, how it serves as an advantage as well as a disadvantage as well. So to overcome this particular problem, we have this one. What is this? Linked list. The main benefit of linked list is that it has not a fixed size, and we can try to dynamically change it every time we need it. So that is the best part of having a linked list. Can anyone? Can anyone say how singly, doubly, and circular linked list would work? I think we discussed last class. What is that? Don't you remember? Right. So I got one answer in the chat. Mhm. Having a connection with one direction, that is a singly linked list. So which means only the one which will come next. If you have a node first node, only the link will be going to the second node. So that is there. That is a singly linked list. If it is a doubly linked list, even that node which comes front or which comes later, both ways it is connected. That is doubly linked list. And if it is a circular linked list, simply the last node is also connected to the first node, which is making a kind of a circular structure. So you can see singly, doubly, and circular from this diagram. So even we started with this, right? So see, this is how you can insert some new node in a linked list, right? If you want to insert at the front, it is quite simply there is another node here which is called as a head node, right? So if this is the head node, actually the first node should be connected to the head node. So already this is connected to here. Now, if you want to insert a new one, simply you put your node here and try to remove the link from here, and you connect this first node to the head node. And after that, this connection will be done here. This is how we insert any node in a linked list at the start of a node. Now, the other possibility of inserting can be seen here. As you can see, inserting a new element to an empty list is so simple. Just you insert an element and point that head here. And inserting at the end of the list and the beginning of the list is also possible simply by changing these uh, connections. I mean, these pointers pointing to the next nodes and all, right? And inserting after is also common. Simply, if you think that this was the previous way, this was the previous way, this one, if this was the previous way the your linked list existed, and if you want to insert a new node here, earlier this would be like this, connected here, right? Now, if you want to insert something in the middle, you try to break this and you connect it here, and again this will be connected here. So you're just inserting something in the middle. Okay, this is there. And just like the start of the linked list, if it is at the end of the linked list mean, simply you place it at the last and you try to, just like for that one, if you connect the head node here, you will connect the tail node to the last node. Okay, this is how the insertion works. So the next part is about deletion. So deletion is simply very much similar to how you do the insertion, right? There you try to remove the nodes and just plug it to a different place, right? Similarly, here also you remove them and do, right? So remove element at the first. Yeah. ICT 32, any issue? Okay, so remove element at the first means simply if this is your node, if this is your linked list which is already available, if you want to remove the element at the first, which means in this scenario, this is going to be your first element, right? So if you want to remove this, simply what you can do is just try to remove them. And if this is your second node, you have to move this and connect it to this head node. This is how you remove the element which is located at the first. Then this is how it works. See, A was your first element and you want to remove this A. So what you will do is after unlink, see this is a dotted line shows that the link is removed. After removing this, you are connecting this, the second node to the head. This is how it works. Then removing element at the last, right? So removing element at the last mean if this is your one, see always the last element is pointing to the null. Whichever the last element, it will point to the null. So now if you want to remove this particular element, what you have to do is first you have to come back up. If this is your last node, come to the node which is before the last node, right? Try to point this to null and remove the last node. This is how you remove the last node. See, remove last mean first you have to come and traverse and come to the node which is before the last, then try to point this to a null pointer and simply remove the last node. Then a third way of removing is like removing a given element of the list. So imagine that this is your list, right? So this is your list. Let me clear the other stuff. If you take this here, right? If you take this here, you have this is your head node, and you this imagine this is your last node. Okay, this is your last node, and this is null. Now 3 is your first node, 8 is your last node. If you want to remove any element, for example, you are going to remove this 5 from this linked list mean, simply you come to the element which is before 5 and you try to link it to the next node, and earlier it will be like this, something like this earlier, right? Now what you do is you try to unlink from here and try to link it to the next node and simply remove this element, right? Although it may look like fancy things to you, how we are doing in the with a pen and paper, whenever you are deleting certain things, this is how it works within the computer. You just type some few lines of codes and this is how actually it will work, right? So you can see this. Okay, head so from here you can see which is the first node here. Can anyone tell me which is the first node here? 3, 5, 7, 8. Which is the first node? Which is the first node from here? Okay, 3 is the first node. The last node is 8 because it is pointing to the null. If you want to remove 3, which is the first node, I'm just going to revise everything at once now. You can have a look. See, if you want to remove the first element, which is at 3, if you want to remove this, what you can do is simply remove the link that it has with the head. After that, you try to connect the second element. This is how you remove the first element. And the same thing, if you want to remove this 8, which is the last element, what you can do is remove the link it has with the null and move here, whichever which is available before the last node, point it to the null. So the first element removal is like this, last element removal is like this. If you want to remove something in the middle, similarly, go to the element which is previously linked, remove that link, and try to put it to the next after and remove that node. So this is how the removal process works in a linked list. Is that clear? Is that clear? Is that
Yes,
clear?
yes. Yes,
Okay.
ma'am.
Okay. Right. So that is about the deletion in a linked list. After that, we will see what is a searching, right? So searching mean uh, uh, I already told you there are two things with a search. One is called as searching, the other is called as traversing. Searching means simply you should know what actually are you searching for, any key element or anything what you are trying to search. Okay, so here what you will do is you can read how the algorithm really works. First you have to make, just a moment, first you have to make head as the current node, I mean the first node. After that you try to run a loop and check whether the particular current node until it turns null. Why null mean? You're going to go up until the last node to check this, right? In each of these iterations, you have to check whether the current node is equal to the key node. Key is the one which you are searching, right? So if you're searching that, to each iteration, you can check if the key of that node is equal to that particular item. If the key is equal to the current node, you get that. If it is not equal, you move to the next node and continuously search for the next element. So you can see here, for example, the search key is equal to 20. So you have a temporary element which is called as a temp or the current node. Now your current node is equal to the first node, this one, the head node, which is this one, right? So you're going to check whether your search key 20 is equal to here, but this is only 10. So what you do is you go to the second iterations and check when I is equal to 2, you come to the second node and make this as your current node and check whether this is equal to the search key. This is 20 and the search key is also 20. Yes, now you have found it, returned true and the program ends here. This is how the search key will work. And if the same thing, if your search key is equal to 30, At the first iteration, you come and check here the temporary, your temp value hold, the current node is 10 and the search key is 20, it mismatch. So go to the second node. So sorry, we were searching for 30. So you check the second node, it is 20, but the search key is 30. So you iterate and go to the third one. So it is 30, this is also 30, it match, it returns true, and the program ends. This is how the search works in a linked list. So you can see the overall, there are many advantage and disadvantage of having this linked list. Just like I told you before also, whenever you are learning any data structure, try to find out what are the advantage of that and what are the disadvantage of that, because based on that only you will decide whether you are going to use that particular data structure for that particular functionality. Okay, so you see, dynamic size mean, why is it dynamic? Because you can change, even though you start a linked list of only like 5 or 6 nodes, but if you want to extend it to 10 nodes or something, you can do it, right? So that is why it is called as dynamic in size. And unlike the, sorry about that, unlike the arrays, which is very difficult for the insertion and deletion. Why? Because there are a lot of data movement. Even when you want to insert something in the middle, or if you want to delete something in the middle, you have to do a lot of data movement, not like just cutting a link in the middle. So to overcome that issue also, people introduce this linked list. So linked list has efficient insertion and deletion, and also it is believed that it has memory efficiency. Why? Because you know, at the start, if you thought you need 100, you can just create with 100, and even if you need to extend it up to 1000, no problem, you can simply keep on inserting the nodes and continue, right? So that way it becomes memory efficient. You don't need to already plan everything and have everything before, and it is not stubborn. No, just like the array, you can't change in the middle or something like that. It can change anytime. Therefore, the memory is also efficient here. And even the implementation is also very easy, right? And the navigation, searching, traversing is also very easy with a linked list. But at the same time, this linked list also have some disadvantages, mainly because of its pointers. Because if you take array, we have only the details about the array data, right? And we have some index, that's all. But here, if you consider a linked list for every node, you should know which node is at coming next, right? So if it is a doubly or circular, you have lot more data. I mean, the metadata is more than even the node data. So they are, because of that, the excess time and the memory, extra memory is also required to store the additional data. So because of all these disadvantages, we still follow implement certain things with arrays, but whenever we are not very sure whether the what is that the size will increase or there will be more number of insertion and deletion, we use this linked list. If not, we always go with the array because it is a basic data structure, right? So overall, try to have an idea. Both are linear data structures, arrays and linked list. Array is static and linked list is dynamic. So by static, what I mean is once it is created, it has a fixed size. If it is a linked list, you can see if it is created, you always have the chance to even extend it or even diminish it. So that is there. Okay. This is the overall summary you have here. Linked list is a linear data structure which is used to store a collection of data with the help of nodes. Each node contains data and links to the other nodes. The size of the linked list is not fixed and it can grow and shrink as and when required, unlike arrays, right? So this is one of the benefit of having a linked list. The consecutive elements are connected by pointers. You have a kind of a chain in the middle, which is called as pointers. The entry point of a linked list is known as the head. The last node of the linked list points to null. So whatever, you don't need whichever the node is, if there is something in the if there is a node and if it is pointing to the head, it can be anywhere. If it is pointing to the head, that is the first node. And similarly, the last node is identified how is it connected to a null pointer. And the memory is not wasted here because extra memory is consumed as it also uses pointers to keep track of the next successive node, right? The main issue is here only because we need a lot of memory overhead mainly because of the additional data we have here. Okay, so that is about the linked list. Like up to now, do you have any doubts related to arrays or linked list? You can please come up so we can move to the next topic. Any doubts you have? Something it's clear. How about others? Any doubts you have? Sorry about my throat. I'm unable to speak clearly. Please bear with me for some time. So, in case you have no doubts, I think we can move to the next topic. Okay. You see my screen, right? Do you see my screen?
Yes, ma'am.
Okay, so I think we can start a little bit of stack also today. So just like the other one, arrays and linked list, stack is also one of the very popular data structure because stack is used in many different types of implementation. So mainly, the main so if you check this one, stack is having a kind of a property which is called as first in, last out property. So making use of this property, we try to implement certain applications. So whenever we want to use this kind of a property, first in, last out application, if we want certain properties in such kind of an application, we try to use this stack. So this is also a dynamic data structure. You can just imagine the word stack or the data structure stack, this one, the data structure stack, like this one, a stack of books or a stack of plates or just a casual English terminology, stack. So you see, if it is arranged in this way, like imagine, for example, one person came and put the book here, and the other person came, put the book here. Likewise, like three, four, five, six people have put the book, right? So whenever you're going to take the book out of this, right? Although this was put first, second, third, fourth, fifth, and sixth. Although this was put in this order, just tell me whenever you are trying to get the book out of this, which book will be taken out first? The first book or the sixth book? Which book will be taken out first? Huh? Which one? Sixth one, right? Because that is how our, like, whenever we try to, whenever we try to remove it, we always remove the one which is at the top. Just similarly, the plates also, if you are arranging the plates in the same order, like stack of plates in the same order, whichever the plate is at the top will be removed first. So that is called as stack. So this concept is very much useful in certain applications. Like you want to find out which is the latest one, right? So just think, okay, we will do this way. Like you are having, I think I already have given this example. Just I'm doing I'm doing a word processing thing, right? I'm doing a bold process, right? I'm doing a bold process to a word document. I'm doing. After that, I'm doing italic. After that, I'm doing like what? Font size, reduce or something. I'm doing these three activities in a Word document. Now, if I press the button Control plus Z, right? If I do this Control plus Z undo operation, which will be undone first? Tell me, which should be done, which should be undone.
Third
If
one.
I, the third one, font size reduce. So here, if you want to implement this undo function in a Word document or wherever, PDF or wherever, even in email or wherever, you should have a track record of everything in an order, right? Like an order, you have to have an order and have a record of everything, and you also should know which should be the very latest one which done. So maybe if you are using this, actually this data structure, this stack data structure, and store this bold here, and store this italic here, and store this font size increase here. So whenever we try to remove, I mean, do something like undo, automatically the one at the top will be undone. So in this situation, whatever the data structure we have to use is this stack. So the main property of this stack is called as first in, last out. Whichever came first will be last out. So this is the way how the stack is working. Okay, so with that introduction, let's have a look at the other stuff. So stack, you can see stacks and queues are two data structures where insert and delete operations are applied only at specific ends. So as we saw in the previous one, the two things we saw, the array and linked list, they have a possibility of inserting the what is that, the data at the middle or data at the end, or wherever we do, right, we end. But if you take stacks and queues, it will allow you to add or delete only from certain end. That is why it is called as controlled linear list. Although they are linear data structure, they have a special name called as controlled linear list. Why? Mainly because it will allow both insertion and deletion only at the specific end, and it has a structure. The order can be a last in first out or the first in last out order, which means whichever the element which is inserted at last will come out first, right? Or the other way, whichever the element that was inserted at the first will come out last. So whichever the element that was inserted at the first will come out later of a stack. Simply you can remember, whatever the element which was inserted last will come out first. Or if you can tell it in the other way, whatever the element which was inserted first comes out last, or inserted last comes out first. So this follows a structure called as first in last out or last in first out method. So this is for the stack. Since it is restricted to uh, this kind of an order, this is called as controlled linear list. Okay, so you can see here, you are inserting every item like this. So whenever the two keywords we use for inserting and deleting in a stack is push and pop. Push means you try to insert a data. You try to insert an element into the stack. Pop means you try to remove that element from the stack. So that is push and pop. So here, if you try to push an item to the stack, it will always come at the top. And when you try to pop item, even if you want to remove the item from here, like here, you have to first remove from the top and come to this level. So this is why it is called as a controlled linear list. All right, so these are some of the examples where the stack is used in real world. So stack of books in a bookshop, CD or DVD stand, call center systems, undo redo mechanisms. So even if you want to trace the history of a web browser, whichever you browsed latestly will be available. Then call log, email, Google Photos, or whatever the one which was happened latest will come at the top. YouTube downloads, notifications, and all. All right. So if you take the stacks, there are different types of stacks available. First one is called as a fixed size stack. Fixed size means once you have created, just like an array, it cannot grow or shrink, right? And it is fixed. For example, if you made a stack of with 5 slots available, it is fixed. You cannot either grow or shrink, right? And whenever the stack is full, and when you are trying to add an element to it, you get an error called as stack overflow. You have heard this term before, right? Stack overflow. Do you know? Have you heard this before? Stack overflow. The word comes from here only. Whenever the stack is full and you try to even add more, like only there, it's simply there is a room which can has the capacity of only 5 people. If you're putting the sixth person inside, automatically it is an overflow. That is called as a stack overflow. And the same way, the other way around, if the stack is empty and you try to remove them, so I told you the removal is always done from the first. You take whoever the person at the front will be removed. So until all the 5% is removed, and if you're still trying to remove the next also, underflow error will occur, right? Then the second type is called as a dynamic size stack. Unlike the static size stack, here this can grow and shrink dynamically. When the stack is full, it automatically increases its size to accommodate the new element, right? Whenever it's full, we don't get any error. We don't say the stack overflow. What we do is it will automatically increases its size. When the stack is empty, it will again decreases its size. So it is like a kind of a dynamic allocation is done in a dynamic size stack. This type of stack is implemented using a linked list as it allows for easy resizing of the stack, right? If you want to resize the stack, it will be done like this. So these are the possible operations. So whenever you learn a data structure, again, I repeat, you have to learn about the basic operations also in that, right? The basic operations in the stack are push, pop, and peek. Either we tell it as a get top or even we say it's like a peek. So remember these terms, right? Push, pop, and peek. It has only one meaning. Push mean insert, pop mean delete, peek mean get access to the topmost element. So these three are some basic operations that we do with a stack. In addition to that, we also have certain other operations like how you initialize a stack and we check whether the stack is empty. Before we remove the stuff, we always, before we throw an error, stack is empty, error, like underflow error, we always check whether the stack is empty and we try to pop from them. Or we even check whether the stack is full before we put one more item into that, we check whether the stack is full, right? And we also can get the size of the stack. So these are the major operations with stack, and these are also some other operations. So we will see the first one. Push means how you insert an element on the top of the stack. So this has always only one parameter passing through this. Push with along with that we give the element also. This operation will simply place the element at the top of the stack. For example, see the stack is empty here. You're going to push one, it goes at the top. Then whenever you push 2, it comes above 1. If it is push 3, it comes above this. It comes above this and comes above this. So you can see a series of push is done. And every time you push one element into that, it always comes as the top of the stack, right? Is it okay? This is how the push works. There is no other order, like you don't push it in the middle or you don't push in the end, or there is no such stories. If you push, it will always come at the top of the stack. That is why it has a control list, no? So you don't need to think much. Simply if you push, it will always come at the top of the stack. Is that clear? So
Yes,
you
ma'am.
in along with this method push, you also pass the element that you want to push. After that, pop. It removes the element on the top of the stack, right? The element is popped from the top of the stack and is removed from the same. So similarly, pop means this is also similar to that. You can just send pop. You don't even tell pop 5 or pop 3. You can't tell. Why? Only the element which is at the top will be removed. You can't arbitrarily go and remove the third or the fourth element to remove. You always get to remove the topmost element only. So you give the code pop and it will always remove the element on the top of the stack, right? Then the third function is peek. So peek mean it is how you try to check the topmost element. So pop is will get the topmost element and delete it, but peek is just check and display to you. Just to find out the topmost element, you try to pass this method peek. So it will retrieve or fetch and just display you which element is at the top of the stack. Push push any element on the top of the stack. Pop, remove the element which is at the top of the stack. Peek, just retrieve the element which is at the top of the stack. So these are the three basic operations that you can do with the data structure stack, right? Remember, it is push, pop, and peek. Okay. So far, you have any doubts? Do you have any doubts so far? Any doubts you have? Okay. Right, so this is here. So the other operations, as I told you, in addition to the major operations, is stack initialization. So how you just initiate one stack in an empty condition, how you initialize a stack is here. After that, there are also two functions I told you. One is empty and is full. This is mainly to check whether to avoid any potential errors, because whenever the stack is empty and you try to pop element from that, we get the underflow error. And whenever the stack is full and we try to even push some more elements into that, we get stack overflow error. So to avoid these errors, we before we either push or even pop, we either push or pop, we try to check whether it is empty or is full. So these are the two functions. I think whenever you learn the practical one, you will learn how to do implement this function as well. Right. So I think we discussed this earlier also. If the stack is already full and we try to insert more elements, so insert more elements mean you try to push more, it will give you overflow error. And if the stack is empty and you try to delete more elements, still you are deleting, that will cause you underflow error, right? So these are the two errors that you encounter when you are dealing with stack. So just like before, the application of stack is also like there are many different applications, right? So one famous one is the undo redo operations. Even we do the evaluating the expressions like converting to infix, postfix, or prefix notation is also done using stack. Then even your browser history, whenever you are dealing with Chrome, even your browser history is saved in the form of a stack. Then only whichever you recently accessed will be at the top. Even you check whether your parentheses are balanced, that is also we implement using stack. Right. All right. So we will see a simple application of having a stack. So reversing a string is one of the application of stack. I can show you here. See, what we do is if you want to reverse a string, right? Maybe I will ask the demonstrator also to demonstrate how the stack is used to reverse a string. For example, if you take a string hello, Helllo, the reverse order would be Olleh, right? So how you do it using stack is you simply push everything one by one to your stack and you try to pop it out in the reverse order. So you can, what you can do is first you push O, then L, E, and H. So in the order you push them, it appears here. But whenever you are trying to pop them out, whatever at the top only will be popped out. So you see, whatever you pushed here will be done as a reversing. This you can practically do during your practical class and check how you can use a stack to reverse a string. And the other application is the checking the validity of an expression containing nested parentheses. So you know, for example, if you are having even a code, uh, even Excel or wherever, you must know that whenever you open a parenthesis, you have to close. Even you open a bracket, you have to close. So every open bracket should have a closed bracket. So this also checked using the this text only, right? This also you will be practically implementing and checking. But this one, I will teach you how this is done in a theoretical way also. That is how you evaluate an arithmetic expression, right? Generally, in a tone, it is we write any arithmetic expressions like this a plus b, right? But due to some computational efficiency, right, what people try to do is they try to change this to a prefix or a postfix notation so that we always have some kind of computational advantage, right? So for this also we use stacks. We try to store everything in a stack and what people, I mean, what the programmers does is we try to convert our general arithmetic expression, because whenever you're going to add 5 plus 3, we write it in the form of 5 plus 3, right? But in an infix notation, we write it, in infix notation, we put our the operators, the plus operator in the middle. That is why it is called as infix notation. But same time, this infix notation can be also written like a prefix notation and a postfix notation. You can simply see where your plus mark comes. If it is before the expression, it is called as prefix notation. If it is after the expression, it is called as postfix notation. If you use these kind of a thing, we get some computational advantage. So because of that, there are even some calculators which convert the infix expression to prefix or postfix and try to do the calculation in a more better way, right? So here, the next part will be, we will learn how we do the postfix or the prefix notation, right? I think about this, I can't speak more than this today, right? So I will upload this also. Please have a look and come. Next class, I'll teach you how to convert from this infix to postfix. Okay, I'm so sorry, I'm having a very sore throat, right? So can we continue in the next class? This one. Okay. If you have,
Okay, madam.
yeah, if you have anything, we can just discuss that, and we can continue with the next class, right? I will just post this. Please have a good idea about this infix to postfix income, because this is very useful and it is also interesting, right? I will teach you in the next class, but meanwhile, I will upload both slides today, the link list and this one. Okay. Sorry about that. See you all next week then. Thank you.